Hello, everyone, and welcome back to your Physical Geology lecture series. So I'm Professor Hurt, and you are most welcome. We're going to be talking again about kind of getting you ready for physical geology. These are kind of introduction lectures. And now we're going to be working a little bit on global geography, specifically latitude and longitude, because as we go through this course, we're going to be talking a lot about, of course, the Earth, and we're going to be talking a lot about latitude and longitude. I'm going to be using those constantly in our lectures. So, I want you to know what the heck that is. And, of course, I'm sure you've heard it before, but I want you to understand more in depth what it is. Okay, so we're going to go over the kind of the basics of latitude and longitude today. So that's our goal. And you got your lecture assignment number 3, I hope. I got mine, so I'm going to be checking, making sure I'm hitting all the important points here. So I'll just go along. I don't want to waste any more of your time here with making much ado about nothing. So, in order to locate yourself on a globe, on a sphere, we have to kind of use a special system. And so that system that we use is latitude and longitude, right? It's a grid, but it's kind of a weird grid because we have to fit it over a sphere, and that's why it's a little bit strange and hard to get used to, and it's kind of hard to think about as a grid on a sphere, right? So first of all, we have north to south divisions, and we have east to west divisions. So we have things that go from one pole to the other, okay, and those lines are the lines of longitude, right? And we actually have a name for them. We don't call them lines of longitude, we call them meridians, okay? Meridians. So lines of longitude are meridians. They go from pole to pole, okay? They go from pole to pole. So every meridian starts at the North Pole, ends at the South Pole, or vice versa. I guess you could say it the other way. It starts at the South Pole. But the point is, it goes from pole to pole. That's the important thing here, okay? East-west divisions are things these are the lines that are going east to west. They are different. They don't all begin and end at certain points. They make little circles, what are called small circles, around the Earth. So you can see this one, and now these lines of what are called latitude are called parallels. And they're called parallels. Guess why? It's because they're parallel. They don't touch. Here's a question for you. Are meridians parallel with each other? No. Remember, parallel lines don't touch. Do meridians touch? Oh yeah, they touch, right? They all touch at the North Pole, they all touch at the South Pole. Okay? So parallels are lines of latitude. Now here's the thing that gets a little bit confusing. Latitude goes east to west. They're circles that go east to west, but they tell you how far north or south you are. Longitude, meridians, they start at the North Pole, end at the South Pole. They go north to south, but they tell you how far east or west you are. Okay, so is that all clear as mud? So parallels are called parallels because they're parallel, meaning they don't touch, they don't intersect. They're the lines of latitude, and they can vary anywhere between 0 and 90 degrees. So at 0, you're at the equator. Okay, so at 0 degrees, what we call north-south. Okay, so latitude, you can go up to 90 degrees north. You can go up to 90 degrees south. You can't be at 91 degrees north or 91 degrees south. That doesn't exist, okay? So you can be at 0 degrees, and that is the equator. So you're right smack dab in the fattest part of the Earth, okay? For longitude, for meridians, they all intersect at the North and South Pole. These actually can go from 0, numerically 0, all the way to 180. And you go from 0 to 180 to the east, or 0 to 180 to the west, okay? So you can see that we divide the Earth into these different, what are called hemispheres, right? Hemispheres, they're like half circles, half spheres. So there's the northern hemisphere, right? There's the southern hemisphere, there's the the western hemisphere and the eastern hemisphere, okay? So anyway, you can't have 181 degrees west or 181 degrees east, right? Because that doesn't exist, right? So meridians only go up to 180, right? Does that make sense? So meridians only go up to 180. So you can be up to, like, for example, 150 west, 150 east, etc., etc. When you give answers on your lecture assignment, make sure that you include, so for example, maybe 90 degrees isn't a good example, but 35 degrees if you say 35 degrees, I don't know if that's a meridian or a parallel. So you have to put north, south, east, or west. Okay, tell me what hemisphere you're in. So for example, this meridian or this parallel right here, I'm going to draw, right? Okay, this one right here that I circled. Okay, you see that? That's 30, right? So that is 30 degrees north, right? This one down here is 30 degrees south. Okay, so if you don't tell me north, south, east, west, it's wrong because I have no idea what you're talking about, right? So if you just, if I ask you what parallel is that and you just say 30, that doesn't completely answer the question, right? So now for meridians, the baseline meridian is 0 degrees, and it is arbitrarily chosen because I don't know if you noticed this, but unlike lines of latitude, you notice how lines of latitude are all different. Like this one is kind of, the 60 is different from the 30, right? See how like 60 is shorter, 30 is longer, et cetera, et cetera. These are all different, right? You can all distinguish them. You might notice that meridians are not like that. All the meridians are exactly the same length. Exactly the same length. Why? Because they all start at the North Pole and go to the South Pole. So they're all exactly the same length. So we have to kind of arbitrarily pick a prime meridian, a 0 degree meridian, okay? That is the one that goes through Greenwich, England, okay? That is the one that goes through Greenwich, England. So if you look at number 2, you got your lecture assignment there, right? And that number 2 is kind of a hard one. I know a lot of people have trouble with that. So if you can kind of imagine, you're looking down at the North Pole. So you're looking down on the Earth. And those big dark lines that you see, those are the meridians that are extending out from the North Pole. And I'm asking you which ones are those. So that's what you kind of have to figure out. Now, one thing I want you to notice here is that this, I'm going to point to this one, this meridian right here, right, that's going down there, that one is actually going through Greenwich, England, right? Do you see that? Can you see that on your lecture assignment? It's going through Greenwich, England. So if that meridian is going through Greenwich, England, which meridian is it? There. So the baseline parallel is, now we switch to parallels. The baseline parallel is the equator, right? That's the one that goes through the fattest part of the Earth. You can see right there. Okay, so I think I have a question like, do I ask you, yeah, number 8. I say, what are some countries that the equator goes through? Well, you can answer that right here, right? So there's Colombia, Brazil, right? This is the Congo. Looks like it kind of goes maybe through Tanzania, Indonesia, right? So there's a lot of countries that you could put right there. Okay, so notice how parallels, those are the lines of latitude, go completely around the Earth to form a circle, right? You see how they form all these circles? So this picture, I took out all the lines of longitude. I just show the parallels, the lines of latitude. You can see they make all these circles, okay? Circles that cut the Earth into 2 equal hemispheres are called great circles. So if it cuts the Earth into 2 equal hemispheres, they're called great circles. If it cuts it into anything else, so one bigger piece, one smaller piece, it's called a small circle. Okay? So if I cut the Earth along this is the equator right here. Okay? If I cut it like that, I cut it into 2 equal halves, right? That's a great circle. If I were to cut the Earth like this up here, I would have a smaller piece and a bigger piece, right? Therefore, that's a smaller circle. That's what's called a small circle. So of all the parallels, there's only one great circle. There's only one great circle, and that is the equator. Okay? Everything else, every other parallel is a small circle. So now you notice here that the meridians are not circles at all per se, right? Because we have some, with all of them start at the North Pole, end at the South Pole. So really they're not circles at all. They're arcs. They're lines. They're like a curving line that arcs from the North Pole to the South Pole. So meridians are not circles, okay? So they start at one pole, end at the other. Every meridian, however, combined with its opposite, makes a great circle. What does that mean? Well, let's say I was to take the prime meridian here, okay, and I were to combine it with the one directly opposite of it, the 180-degree meridian. That would cut the Earth into two. See how I cut it right? Oh, you can't see what I'm doing here. I cut it right down the middle, right? So that makes a great circle because I cut two equal halves, all right? So I actually don't even know. I might not even ask about great circles too much on here, but it's kind of an important concept to understand. So anyway, moving on. I just want to show you this. I don't know. I'm kind of thinking maybe I should skip it because I think it kind of confuses people. But I'm gonna. Well, I don't know. Maybe I should skip this because I notice it really seems to confuse people, and they put the wrong answers on there. What this explains, I'm trying to explain how parallels work, but I'm going to just skip it because I think people get confused by it. So anyway, just to review, lines of longitude, right? Start at the North Pole and at the South Pole. They're called meridians. The basic 0-degree meridian is the prime meridian, right? The other meridians go all the way across the other, either east or western hemisphere, all the way to 180. You can't go beyond 180, right? Latitude, on the other hand, those are composed of circles that are mostly small circles, except for the equator, which is a great circle, right? And all of the lines of latitude are parallel, right? And then we call them parallels, okay? So let me look at some of the questions here, make sure I get everything. So number 2, you have to fill in and give me the names of those, or not the names, but actually the numbers. Identify those 4 bold lines that are shown here. So you got those 4 lines, and you have to fill in the blanks, right? Which numbers they are, okay? So that's what you do there. Number 3 says the special name given is 0-degree meridian. I think you got that. Do meridians intersect? Parallels intersect? Let's talk about number 6 and 7. This says which parallel is furthest from the poles, which is the closest. I thought I eliminated question number 7, honestly. I don't like that one very much, but I'm going to give you the answer to that. So which parallel is closest to the poles? That's a little bit confusing, but the parallel that's closest to the pole is the pole itself, right? It's the 90-degree north, the North Pole, or 90-degree south, South Pole, okay? Those are the ones that are closest. I keep thinking I take that question out and then somehow it survives every semester. I have to update that. So, but that's number 7. Number 6, you should be able to figure that out on your own. Number 8 we covered. Let's talk about 9 and 10. We're going to talk now a little bit about seasons. So that's kind of a quick overview of latitude and longitude, but I want to talk about seasons and how climate also relates to latitude and longitude. So one very important thing you need to know for this class, comes up a lot, is that our Earth, of course, is rotating around. That's what creates the phenomenon of a day, right? You know, the sun comes up, the sun goes down. What's that from? It's from our rotation on our axis. But that rotational axis is actually tilted relative to you can see the GIF here of this Earth going around and around and around. That axis of rotation is actually tilted relative to our plane of orbit, okay? So we call that tilt, it's 23.5 degrees from because you would expect it, right, to just be perfect 90 degrees, right? But it's actually tilted 23.5 degrees off kilter, okay? So that actually creates the seasons for us, and that creates 4 special positions. And those 4 special positions of Sun, Earth geometry create the 4 seasons. Okay, so if you want to know what the seasons are about, it has everything to do with Sun, Earth geometry. Everything to do with that. Okay, so let's talk about this a little bit. When the Earth, so here you can see the sun's rays are coming in, right? when the Earth is pointed, the axis is pointing directly at the sun, okay? So let's say you're the sun as a camera, right? And this is the axis, and it's pointed directly at the camera, okay? It's pointed at it, towards it, I should say. Not directly at it, but pointed towards it. That is the summer solstice, okay? So the Earth is pointed towards you. I'm thinking, should I have brought a globe? Maybe that would have been a better way to explain this, but too late now, I guess. Oh, actually, you know what? It's not too late. I can pause this. I'll be right back. Okay, look at me. I'm back with my globe. So anyway, here's the globe, and here's the axis of rotation right here, okay? Now, when I turn this towards you, let's say you're the sun, okay? When I turn this towards you, you notice how you can see the axis of rotation. It's pointed towards you, okay? So that day corresponds to the summer solstice, okay? That's when the sun is directly overhead in the, if you pay attention to the slide, it's actually directly overhead a special point right here. Whoops. It's directly overhead at a special point called the Tropic of Cancer, 23.5 degrees north. Does 23.5 sound familiar? It should, because that's the tilt of our axis relative to our orbital plane, right? What's called the ecliptic plane. So when our sun is directly overhead that Tropic of Cancer, that's called the summer solstice. Now in the winter, what's called the winter solstice, it's backwards. So now you notice here's the you can see me looking over the Earth over here, and I'm looking at the rotational axis right here. And notice you can't see it. I can see it, but you can't see it. Remember, you're the sun. So now you can see that the northern hemisphere is pointed away from it. So when it's pointed away, that creates the winter solstice, right? And that's when the sun is directly overhead right here, the Tropic of Capricorn. Okay, so that's summer for the southern hemisphere. It's winter for us, right? Now, there's another situation, actually two more situations. The sun can be over the equator. That happens 2 times per year. So the sun is only directly overhead the Tropic of Cancer during the summer solstice, and then it's directly overhead the Tropic of Capricorn at the winter solstice, and then it's overhead the equator twice per year. So in those situations, that when the axis is pointed directly to the left or to the right, see how now here's the axis of rotation right here. It's not pointed towards you. It's not pointed away from you. It's kind of pointed to the right or to the left. That's called an equinox. Okay, so that's when the sun is directly overhead the equator. Okay, so now I lost my pen. There it is. Okay. So the tropics are circles in which the sun is directly overhead during one of the solstices. And the Arctic and the Antarctic circles are actually circles in which there is at least one day of the year that the sun does not rise. Okay, so you've probably heard of the Arctic or Antarctic circles. So the Arctic or the Antarctic circles, those start at 66.5 degrees north or south. Okay, could be north or south. And you'll notice at 66.5, that seems like a random number. It's actually not a random number at all. It's 90 degrees minus 23.5, which is the tilt of the axis, right? So that's the tilt right there. So anyway, I have a question there, number 9. It says, what's the climate like around 75 degrees south, right? 75 degrees south. So anything that is between 66.5 degrees north or south to 90 degrees north or south, that's going to be in the Arctic Circle or the Antarctic Circle, right? So what's the climate like there? Just is it warm or is it cold, right? So hopefully you know what it's like in the Arctic or Antarctic Circle, right? On the other hand, number 10, you'll see I ask you, what's the climate like around 10 degrees north or south? That's close to the equator, right? So what is the weather like close to the equator? What's the climate like? So you'll see that there's kind of a negative correlation between your latitude and your average temperature, right? The higher the latitude, the greater the latitude, the lower the temperature. The lower the latitude, closer to the equator, the higher the temperature, okay? So, Anyway, let me look at some of the next question. Oh, number 11. Number 11 is kind of a difficult one. Okay, so number 11, I ask you to draw in 4 lines. One representing the equator. Oh, actually, that's already done for you, isn't it? Another, the prime meridian. Now, be careful with that. Okay, be careful on number 4. I'm sorry. Number what are we on? Number 11. Okay, be careful on number 11. Notice I say draw in a line. You have to go to the next page to see the circular representation. I say draw in a line that depicts the prime meridian. Remember, the prime meridian is a meridian, so it has to go through both poles and it has to go through Greenwich. Okay, and you'll see Greenwich there, right? So if I take this, you can see whoops, I can't. It's kind of hard to see where there you go. So you see Greenwich right there. So just make sure that your line goes, it's going to arc. It's going to be a curve. It's got to go through the North Pole, the South Pole, and Greenwich. Okay? So be very careful. That's one of the hardest ones. A lot of people lose points on that. So just make sure it's an arc that goes through all 3 of those points. Okay, so now we also have to draw in 45 degrees north. 45 degrees north is going to be a line of latitude, a parallel. Okay, and then 15 degrees east, that's a meridian. Okay, 15 degrees east is going to be a meridian arc that is going to be to the east of the prime meridian, but you should still be able to see it. Okay, so I hope I helped you with that. That's a hard question, but anyway, like I was saying, high latitudes are places that are relatively cold, right? So that's like the Arctic. Low latitudes are places that are between the tropics, between the Tropic of Cancer and the Tropic of Capricorn. Those are relatively hot places. You can see that Corpus Christi is really close to the tropics. It's not quite there, but it's really close. So that's why we're called subtropical. We're almost there, but not quite. Everything in between those areas are called mid-latitudes, and those are called more temperate climates. Okay, so we kind of have more even temperatures, average temperatures. Okay, so we're not hot, we're not quite cold, not quite hot. Okay, so you know number 12. Now number 13. Be very careful. Okay, number 13. Be very careful. So let me go back to do this. So take a look at number 13 on your paper, and be very careful, because you'll notice that this depiction right here that you see up on the screen is actually flipped opposite of what you see in your paper. You see what I'm saying? It's flipped and it's opposite. And the reason it's flipped and is opposite, imagine you were on the other side of the solar system looking at this, right? If you were on the other side of this, you would see a different perspective. Okay, so something would be on the left instead of the right, and winter would be on the left instead of the right, and right instead of left. Okay, so just be very super careful with that. A lot of people screw that up on this, screw up number 13 on these lecture assignments. Okay, so we covered that. So just remember that the solstice, the summer solstice, it all depends on what the axis is doing. When the axis is pointed towards the sun, right? You can see how you all can see the axis. That's the summer solstice. When it's pointed away from the sun, right? That's the winter solstice. When it's pointed directly to the right, right? There's the axis right there. Actually, everything's kind of mirrored in the video, so I don't know if it's to the right or the left. But if it's pointed directly 90 degrees to the right or the left, that's one of the equinoxes. Okay. Now, just realize too, one last thing I want to say. What direction is the Earth rotating around the sun? Notice it's going counterclockwise. We spin counterclockwise, and the Earth rotates around the sun counterclockwise if you're looking down on the northern hemisphere. Okay. So just be aware of all those little things and try to figure out number 13. Okay? Basically, it's actually, if you can just figure out one of those positions, summer solstice or winter solstice or whatever, you can figure everything out just by the direction, because you know the direction of rotation, and hopefully by now you know what seasons come after which, right? You'd be surprised how many problems I get with this, but it's okay. I'm just trying to help you. Anyway, so during the summer solstice, the sun is directly overhead. Which parallel? During the winter solstice, which parallel? So you get the answers to that right here, right? So during the summer solstice, the sun's rays are directly overhead the Tropic of Cancer. During the winter solstice, directly overhead the Tropic of Capricorn. And during either equinox, equator, during either equinox, it's directly overhead the equator. Okay. So I'm going to show you one more thing because they're kind of cool. A lot of people, I thought I had a video to this, but I guess I didn't attach it. But I'm going to pause this really quick and pull a video up because it's really neat. Okay, 1 second here. Okay, I'm back. So I just wanted to show you this. It's a little video of a time lapse. They're at the Polish polar station here, and notice what the latitude is. The latitude is 77 degrees north, right? 77 degrees north. So are you in the Arctic Circle? Yes, in the Arctic Circle. Okay, so you're in the Arctic Circle. So like I said, when you're in the Arctic Circle, I was explaining there's going to be at least one day in which the sun does not come up and one day in which the sun does not go down. If you're at the North Pole, the sun stays up for 6 months of the year and it goes down for 6 months of the year. Isn't that crazy to think? So here's a time lapse showing what it looks like to be in the land of the midnight sun. So they call it the land of the midnight sun because when you're there, it can be midnight and the sun's still up. So you'll see that the sun gets close to the horizon, but doesn't go down. So I'll show you this now. So it looks like it's going to become nighttime, but then it's like, oh, no, I fooled you. And it starts rising again, right? So there's the sunrise. Isn't that kind of cool? You get to watch the sunrise and the sunset at the same time. It's kind of weird, right? Anyway, if you ever live in the Arctic Circle or the Antarctic Circle, that's what it's like. So I'll get back to... Whoops. Get back to our stuff here. Okay, so I think we answered everything up to number 14, 15, 16. The last thing is number 17. So, during the course of this class, I talk about a lot of different locations on Earth, geographical locations, and I just want to make sure that you know where all those locations are. Because if I'm talking about, because some of them are kind of weird, like the Atacama Desert. Where's the Atacama Desert, right? So I want to make sure you know where all those locations are and some other basic stuff. So, first of all, there will be some geography questions on the test. So some things about just make sure that, you know the continents and, the oceans. Okay, so you should make sure there's 3 main oceans, right? Pacific, Atlantic, Indian. And then there's 2 smaller ones, the Arctic and the Southern. So make sure you're familiar with the oceans. Hopefully, by now you're familiar with the continents. I want to show you where some important mountain ranges are. So in this thing, what am I asking for? I'm asking for the Andes. Okay, so you can see the Andes are right along here in South America, on the west coast of South America, right? I also talk about, what else do I ask for here? The Himalayas, right? Himalayas are the highest mountains in the world right now, okay? Himalayas are right there to the north of India, between the subcontinent of India and Eurasia, right? So that's the Tibetan Plateau and the Himalayan mountains, okay? Some other mountains I ask about. Let's see if I mention anything else. I don't think so, okay? So those are some of the mountains, major mountain ranges, right? Some major deserts I talk about a lot. We'll have a whole lecture on deserts. What are some deserts? There's the Atacama Desert. That's right there, just right to the east of the Andes Mountains, especially in Chile. and parts of Argentina. Okay, there's the Atacama. So that's probably one that most people probably haven't heard of. Let me see if there's any other things, rivers. I do talk a little bit about Lake Baikal. Do I have something? Yeah, major lake. So Lake Baikal is over here. It's in Siberia. Okay, so make sure you get that. And that's it. So let me also point out some other things. We asked about where the Japanese islands are, right? Most of you know where Japan is. Okay, there's Japan right there. Put a J. We did the Andes. We did the Himalayas. Gosh, I hope you know where the Gulf of Mexico is by now. You probably swim in it, once a few times a year at least. So there's the Gulf of Mexico. Hudson Bay is actually up here. It's that big bay that's in Canada. And we have Greenland. Greenland is this big island up here. It's kind of looks like it should be a continent, but actually, you know what? It's actually connected to the North American continent. That's why it's not its own continent. It's just kind of shallow water. This is all kind of shallow water that's right here. So it's actually connected. There's also Iceland, which I talk about quite a lot. That's right here. Okay, you see that there on the screen. And Sumatra, which is right here. It's part of some of the Indonesian islands. And there's also the Philippine Islands right here. And I think I hit everything that's on there, right? So, I didn't hit the Aleutian. Let me get the Aleutian Islands. That's that chain of islands that's right off the coast of Alaska. Okay, so those are the things I wanted you to know. They're important because I talk about them in this class, and you got to know what the heck I'm talking about when I'm talking about the Aleutians or Japan or blah 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 blah. Okay, be prepared for a test, your midterm and your final test. Right there, you'll have pictures like this. You'll have a picture of the world, and I'll say, it'll have A, B, C, D on the world. And you have to say which of these shows the location of the Atacama Desert, right? So you got to kind of know where these things are. All right, so that's all I have for you today. It's a quick, 36-minute presentation. So hope you enjoyed it. And I will talk to you next time when we do one of my favorite lectures, which is on Earth structure. So until then, have a good week.